Hello everyone, welcome back to the Web Security channel. In this beginner tutorial, we'll solve PortSwigger's lab, determining the number of columns returned by a query. The lab asks us to perform a union-based injection using the union select technique. And I'll also show another effective approach, the order by probing method. We'll use Burp Suite and a browser, and I'll explain each step clearly. To complete this lab, you should understand how the union operator works. I have a detailed theory video on the channel, and I'll leave links in the description below. Before we start, a quick reminder about ethical conduct. This video is for educational purposes and authorized testing only. Do not attempt these techniques on systems without explicit permission. Purpose and conditions. This PortSwigger lab contains a SQL injection vulnerability in the product category filter. The lab requires us to determine how many columns the original query returns by adding an extra row of null values using a union injection. You will then use this technique in subsequent labs to construct the full attack. What you'll learn in this video. We'll first do a quick test to confirm the parameter is injectable. Then we'll discover the number of columns using union with null placeholders in Burp and in the browser. We'll also show the order by probing method in both Burp and the browser. Finally, we'll confirm the correct payload that returns the extra null row. Now let's open the lab work and start testing. Step 1. We'll now run a quick test in the browser to verify whether the application is vulnerable to SQL injection. Click a product category so the app issues a request that includes the category parameter. In the address bar, replace the category value with a single quote and submit the request. If the site returns an internal server error or an SQL error message, that's a sign the parameter may be injectable. Next, try the single quote followed by a SQL comment terminator, for example --, submit the request again, and observe the result. If the error disappears or the page behaves differently, that also indicates the parameter can be injected. Remember, this is a quick exploratory test in the browser. We'll use Burp Suite later for controlled testing and to craft payloads safely. Now we'll discover how many columns the original query returns using union select in Burp. Inject single quote union select null --, and forward. If you receive a column count error, add more nulls and try again. When the response returns HTTP 200 and the page content changes, for example an extra row appears, the union succeeded and the number of nulls equals the column count. Quick note, in SQL, null means no value or unknown. It's not the same as 0 or an empty string, those are actual values, whereas null means nothing is stored. Because null can fit into any column without needing a specific data type, like text, number, or date, we use it as a neutral placeholder during discovery. For example, union select null, null, this helps us test how many columns the original query has. We already ran a quick browser test and found the application is likely vulnerable. Now we'll perform controlled testing in Burp Suite and craft the union payloads. In Burp, I enable interception, click the category filter, in my case it's the GIFs category, and intercept the GET request. I right-click the request and choose Send to Repeater, then disable interception so the app keeps working. Repeater lets us edit and resend the same request repeatedly. First, I send the request without changes and note the response code in the response panel, it's 200. Next, I modify the category parameter to the payload single quote union select null --. Select the payload. Then right-click on the selected value. And select Convert Selection. Next, choose URL and finally click URL encode key characters. And notice spaces become plus. I URL encode the selected payload so special characters like quotes and spaces are sent safely in the request. This ensures the server receives the exact payload we crafted, otherwise the browser or proxy might alter it or the URL may be invalid. Then I send the request. This time the server returns 500 internal server error, which means the injected union didn't match the original query's column count. So I add another null separated by a comma and try again, single quote union select null, null --. If it still errors, I keep adding nulls one at a time until the response changes. Now the response code is back to 200, and the page shows the success message, "Congratulations, you solved the lab." That tells us the union succeeded. Because we used 3 null values in the working payload, we know the original query returns 3 columns. The number of nulls we added equals the number of columns in the table. A quick note about response codes. HTTP 200 means the web server successfully returned a page. It does not guarantee the SQL worked as intended. In our tests, a 200 response after a union payload often indicates the database executed the query and returned results. But some apps always return 200 even on internal SQL errors. That's why you should always inspect the response body. Look for SQL error text, unexpected blank rows, or your injected markers appearing, not just the status code. You can repeat the same union discovery in a browser by pasting the payload into the address bar. Send a request with the payload and check whether it errors or returns normally with changed content. The behavior mirrors what we saw in Burp. Now I'm running the same test directly in the browser. I click on a product category, then paste the payload into the address bar and press Enter to submit the request. The page returns an internal server error. I'll add 1 null value at a time, separated by commas, until the page loads normally. And now we can see that the page displays correctly. I ended up with a total of 3 null values, which means the table contains 3 columns. This is an inferred or typical behavior during black box testing. We don't have the application source code, so exact internals may differ. Behind the scenes, a SQL engine executes each select and then stacks their rows into one result set when you use union. For example, the application might run select product ID, name, price from products where category gift. If we inject single quote union select null, null dash dash, the database runs the original select plus our injected select and attempts to merge them. If the number of columns matches, the database adds the rows from our injected query to the original results. That's how our extra row appears on the page. Alternative method, order by index probing. Inject single quote order by 1 dash dash, single quote order by 2 dash dash, and so on. When an index greater than the available columns is used, the database errors. The last working index equals the number of columns. Now let's determine the number of columns using the order by method, a quick alternative to union when you want to probe column count. I enable interception in Burp, click the category link, and send the intercepted GET request to repeater. Then I disable interception so the app keeps working. I go to the repeater tab and first send the request without any changes to see how the application behaves. I note the normal response so we have a baseline. Then I set the category parameter to single quote order by 1 dash dash. URL encode the selected value and send the request. The response code is 200. Note that you'll typically see 200 responses as long as the index is within the available columns, which means we need to continue testing and increase the index. Next, I change the payload to single quote order by 2 dash dash and send again, then single quote order by 3 dash dash, and so on, increasing the index by 1 each time until the server returns a database error. When the request finally produces an error, in this case a 500 internal server error, the last index that worked is the number of columns. For this lab, the last successful index was 3, so the original query returns 3 columns. You can repeat the same order by checks directly in the browser by sending URL encoded payloads in the address bar. Thanks for watching. If you found this video helpful, be sure to like and subscribe for more beginner-friendly content on cybersecurity and ethical hacking. And don't forget to check the video description for all the links I mentioned. If you have any questions or suggestions, please write them in the comments. See you in the next one.